Good afternoon, everybody. Thanks to Accel. Very good format, very engaging. I learned a lot from the previous two talks. I'll start with the system prompt, right? All of you are used to working with LLMs. First system prompt is to the previous speaker, Nikesh. He ended with a slide of making an e-commerce LLM in a joint manner. I think that's definitely possible, right? And in India, we should be thinking of building these tools right from scratch. And in fact, that is the theme of my talk. While there are some issues today in thinking about the cost, in thinking about expertise, but really the thing is moving so fast that the technology will move much faster than the organizational appetite to change. So it's therefore good to understand where this technology is trending and what we should be all doing in a moderately long time frame. So broad topics, I want to mention that GenAI should be thought of as a new type of software, just as you had GUI in the 1980s, web in the 1990s, smartphone apps in 2000s. I think this is a new kind of software, and maybe cloud last decade. It shouldn't be thought of as AI data science. I think it's good to frame it more broadly. I want to talk about why this is extremely generalizable, give you a sense of a technical insight. Then I want to talk about various options. We discussed a bit in the last two talks, but I want you to think a bit more broadly. And finally, what can we do in Bharat? We are building LLMs for Indian languages. I want to talk a bit about that, and I want to talk about the use cases that you can shoot for. Firstly, what is very interesting is, for the first time, we have a situation like this, wherein we are building hammers, and the bigger the hammer gets, the larger is its value, right? This is a great situation. I build bigger and bigger hammers, and their value increases with time, right? For example, this is a very big hotel. It was not built with a bigger hammer. We never scaled hammers, right? But with deep learning, we are in a situation where the larger it gets, without doing much else, the value increases. And the one company that really bet on that is OpenAI in the middle of last decade, right? And what that has led to is, if you increase it beyond a certain size, then we get what is emergence. It can do many more things much better. I just want us to reflect on that firstly. I think the previous speaker mentioned how a large community is building these models in the open source. That is only possible because you don't need special secret sauces for everything these models are doing. As a consequence of this, these are older numbers from Assembly AI. As we increase the size of the models, they start doing interesting things. At 8 billion parameters, they solve a few tasks. At 62 billion, few more. And at 540 billion, many more. These numbers in terms of parameters, they are reducing. But the interesting thing is, if you picked up any one of these line items, they were a PhD thesis a few years back. I've spent a decade working on AI, built translation models, built understanding models, etc. for Indian languages, and all of this was very, very hard work just a few years back. But now, these large language models enables us to solve all of them with a single model. One important question to ask is, why is this happening? Why is this one large model able to do all of these things? Take, for example, joke explanations. That's really hard to do. And it not only needs to understand language, but also theory of mind, etc. And I think it's one paper that I think some of you might like to read. This is a paper from 2020, already been almost 3 years. Hasn't seen so many citations. The paper title is Intrinsic Dimensionality Explains the Effectiveness of Language Model Fine-Tuning. I'll spend about 3-4 minutes trying to explain to you what this is, and I think this is an important insight for you to take away with as to why this class of AI is really effective. So, intrinsic dimensionality, let me just define that term. Take any optimization problem. Let's say I'm trying to fit a curve onto some data. Then there is a certain dimensionality to solving the problem, characterized by how many parameters I need to tweak to fit the curve, right? So if it was a quadratic curve, you need a dimensionality of 2. If it was a cubic, you need a dimensionality of 3. Of course, neural models, they have huge dimensionalities, billions of parameters. But you can ask the following question: after I train the model somewhat, how many more parameters should I tweak for it to start doing well on a particular task, right? So I trained a model, what we call pre-training. After I get there, how many more parameters do I have to tweak to solve, let's say, joke explanations well, right? And this is also not well defined because there is a search procedure involved. So people do some kind of approximation. They say, how many parameters should I tweak so that I get to 90% of the best result on that particular task, okay? That's called D90. So it's a complicated definition and very compute expensive to identify, but roughly it tells you the difficulty of solving a problem at a particular stage, right? And with that background, here is one more slightly tricky chart. The chart x-axis has updates. Basically, it's a model being trained, and as the model is training, it's moving towards the right side. There are more updates being made. And the y-axis is D90, this intrinsic dimensionality. And this is done for a few tasks. For example, MRPC is a paraphrase detection task. Something like SST is a sentiment classification, and so on. And what this chart shows very interestingly is, if you take any one of these particular tasks, then the intrinsic dimensionality of solving that task, let's say paraphrase detection, it keeps falling as you train the model on a pre-training data set, right? So what's happening on the x-axis? We are not showing it any of these tasks. We are simply pre-training on more of whatever, books 3 and common crawl and so on. As you do that, the intrinsic dimensionality of solving paraphrase keeps coming down, right? And this is not just happening for one task, but for all the tasks, right? So what essentially is happening is, as you pre-train these models, it is becoming increasingly capable of solving a variety of tasks with much lesser extra data, right? Or it's somehow becoming generally good at all tasks, right? And of course, this was a paper in 2020. This is a model called Roberta. I don't know how many of you have been using those class of models. We built, in fact, something called IndicBERT, which was downloaded on Hugging Face about 200,000 times, but that was still very small. We are right now much, much farther to the right, right? This is maybe 200,000. Today's models are significantly to the right, so much so that this D90, and remember the y-axis here is a log scale, the D90 is 0, meaning even with just prompting, I can solve any of these tasks with these models, right? So the intrinsic dimensionality falling for a range of tasks is the key insight why these LLMs work well, right? And the other interesting part was, this is not just about one particular model. It turns out that if you take models which are of different sizes, then the intrinsic dimensionality also falls as you increase the model size. The previous one was a particular model trained more and more, but the next one is if you start off with larger models, again the dimensionality falls, and again today we are much more to the right of this curve, right? So the intrinsic dimensionality again is close to 0, right? That's why the technical term in context learning works, because you can give a context, you can give few short examples, and it's able to actually do that particular task, right? So this is, I think, an important recognition that we have this hammer that is becoming bigger and bigger, and across a range of tasks, including joke explanation, which no NLP researcher would have thought of working on, is actually possible with these models, right? I hope you got that point through. The next thing I want to talk about is, what do we then do with these models? And we have been discussing this in reasonable detail, so I won't labor on this. But I feel that LLM performance is, of course, obtained by a combination of prompting the model properly, fine-tuning. We had discussed quite a bit about SFT in the previous talk, and also pre-training. And in fact, we were discussing about pre-training also. And I think of this as the full stack of AI. Most people start by prompting the models, and frankly, this is underappreciated. How much performance you can get out of a model by properly prompting it is surprisingly high, right? Of course, the next step to do is once you know what you really want, you can fine-tune it, primarily fine-tune it with what we call SFT pairs, query and responses. And many people are doing this. In fact, OpenAI is making this a commodity now, and I think that's true. Also, you can pre-train models. And last year, maybe OpenAI and Google and a few companies were pre-training models. This year, Meta is pre-training models. Smaller startups like Mistral is pre-training models. Next year, I'm hoping a small startup like ours can pre-train a model out of India. And I think in 2025, most companies should be pre-training models, right? That is how fast this technology is becoming accessible and really allowing you to play across the full stack. Right now, here and now, we have questions like, should I prompt, should I fine-tune, should I pre-train, what is the business model, what is the cost, et cetera, et cetera. But given how fast the technology is trending, I think it's important to think about a year or so down the line, and if we are ready for that, right? So my sense is that the cost and expertise required for all three layers will rapidly fall, and we need to prepare to play across the full stack in some sense, right? And I think this is very exciting because who would have thought that you would have a software methodology like this, wherein you can train such large models that do so many powerful things, and all of us can do that, right? It's not tied to only DeepMind doing it or others doing it, right? And in this context, it's good to discuss in terms of the different options you have when you hit scale. What I noticed in the previous discussions as well was we are quite worried about the cost today because people still are figuring out how to deploy this technology, where does it add value, where is there a customer pull, and I think those are fundamentally important questions to ask in the here and now, right? But let us say a year or 2 years down the line, I would think sooner, maybe a year down the line, once you hit scale, the questions change in nature because you are mostly focusing on the operations cost and not so much the cost of fine-tuning a model or even pre-training a model. In that world, right, in the world where you have hit scale in some sense, the one thing that you can do is use a model like GPT-4, right? And as you saw from the previous numbers, my recommendation also is not to use GPT 3.5 anymore, only use GPT-4 or use an open model, which you can deploy yourselves, right? And in fact, the whole deployment stack, efficient inferencing, all of this is also becoming very, very accessible, right? So one option is take the GPT-4 of the day, right? It could be an Anthropic model, it could be whatever model. There would be one such frontier model that is out there, and that will give you a good cost accuracy trade-off, and people like Microsoft will make it available in a way it is enterprise ready, right? The next thing you can do, and this is something that almost all of you are already doing, is to do RAG, right? If you can ground it on your procedure, on your data, on your user profile, these models can do much, much better. The accuracy goes up, but notice the cost goes further as well because you're paying for all these extra tokens in the context, right? But this is very, very well understood today, though there exist open questions around which embeddings to use, how do you chunk your documents, how do you combine them, and so on. Those are open, smaller questions to figure out. The next thing is you can do GPT-4 with prompt design. And I want to make a statement, that's why I put it much, much higher up there. You can really improve your accuracy significantly by playing with the prompt space, right? We have seen this across different use cases. Please don't underestimate what you can achieve by prompting these models properly, right? And this often takes time. There are now methods by which you can even evolve the prompts automatically. There are methods by which you can use machine learning to improve the prompts. So I think that is one thing maybe a little bit underappreciated now in terms of how to use these models. The cost increases, but not by much. And I think fine-tuning GPT-4 is also an option, right? I have put cost reducing with fine-tuning GPT-4 because the cost of fine-tuning these models is so cheap, right? It's a bit more than the inferencing cost, maybe a couple of times more than inferencing cost, but just imagine what is that giving you. It is giving you the best workload on cloud that you can optimize for your data, right? That's a tremendous power, and because these workloads are so synchronous, the ability to fine-tune that, the cost of fine-tuning actually is negligible. What it might give you is you can avoid very long contexts. You can avoid system prompts and really get GPT to do what you wanted much better. I think previous speaker was talking about e-commerce context, right? You can actually go and fine-tune these for fairly cheap prices, right? And I think this is, again, we should appreciate, we have these synchronous workloads on data centers that can just churn out this one workload very, very efficiently, right? That's why this is all accessible to us at scale, right? So this is the kind of option set that we will have. And in some form, this will be available for open models also. And all of you are already looking at it. You can use a Mistral, you can use a Llama, you can use an Orca model or whatever, and you will have some kind of a trade-off space. This is not to accuracy or anything like that. Likely the accuracy will be lower, the cost will be lesser, but not by a huge amount. You can probably do a lot more with RAG and prompting, probably also to some extent fine-tuning these models. So again, this is not to scale or anything like that, but I think you will have this option. The next important thing for us to think about, and I think this option opens up already in a few months' time for many of us, right? Which is to build your own LLM, right? Actually, it's not that hard to do. It's not that hard in terms of the code being out there. It's not that hard in terms of the cost of GPUs, and it's not that hard in terms of actually serving it at scale the same way that OpenAI or others do it, right? And there are some good examples of this. Microsoft did a keynote a few days back where Satya announced this one particular model. This is a model on Arabic. It's called JES. The paper actually is very detailed. It talks about how do you take a GPT-3 architecture, which was still sort of open source. It is not open source, but at least there was a paper which said what the architecture of GPT-3 was. And they've taken GPT-3 architecture and they have gone and trained from scratch, right? So trained from scratch is they have, I think, about 300 billion tokens of English and Arabic and so on, and pre-trained the model and then fine-tuned it on a bunch of open source data sets. And they are able to hit GPT 3.5 level accuracy on a bunch of tasks, right? So this is a couple of weeks older, and now they have a larger model as well. Another example many of you might have heard about is Bloomberg GPT. Okay, this is a company that sort of invested a bit earlier in this, already by, I don't know, when was this? Yeah, May 23, definitely early by its standards. And the interesting thing here was, while the previous one, they did some things here in terms of the architecture, this particular model, in fact, had a custom tokenizer, right? What this means is, when the data is fed into the model, you have to convert the text into a set of tokens, and it is sometimes useful to have your own custom tokenizer, right? For example, it turns out that in GPT models, numbers are interestingly tokenized. If you had something like 1.314, then the 3-1 after the point would be one token, and the 4 a different token, right? In fact, the speakers talk about this, and it might be much more useful to tokenize numbers much more deterministically and differently, right? So you can actually go and do this. So if you had e-commerce and you had product codes or you had foods, right? You can build custom tokenizers for them. And not only does this lead to more accurate representation, it's also more cheaper. Sometimes you can have entire words or even multiple words as a single token, and thereby paying lesser for inferencing costs, right? So again, this is something that people are doing, and I think that will be an option that opens up already for many of us. The next thing you can do, people are talking about LLMs, large language models, but again, there's an interesting term called SLMs, small language models, right? And it turns out that we are pushing both the boundaries, right? People are trying to build AGI. There's one set of people going after that, but other set of people are trying to say, can I go control this whole stack of training and make a small language model which is very good at the intersection of, let's say, language and a domain, right? And I think there are a few interesting works that are worth looking at. Again, many of you might have seen this. There is this thing called Tiny Stories from Microsoft Research in May. By the way, I was at Microsoft Research, and it's interesting to see how much more mojo there is in a research lab once there's something like OpenAI coming in and pushing you, right? Now, so here what they did is, if you wanted to teach a model to write stories, you don't need to train it on all of BBC, right? Or all of Wikipedia. That's not necessary. Can I train a very, very narrow pre-training data set that teaches a model language fluency and then helps understand what defines a good children's story. And they talk about how to create this kind of a data and then train a model specifically with, in this case, pre-train the model with that data. And there are, and there's a follow-up work which is called Textbooks Are All You Need, a few months later. This was really about, hey, can I take something like coding, where you have GitHub Copilot, right, which is a large language model that was fine-tuned for coding, and train it from scratch to be good on, let's say, something like Python. I only care about Python. Can I make a Python-specific large language model? And what they do is, instead of going and training on Python data in the web, can I create a pre-training data set with large language models in a manner that is highly structured? And a highly structured way of writing data is textbooks. How do we read some topic, right? We typically, I mean, I think not anymore these days, we hardly read textbooks, but you typically have a textbook which teaches you the topics right from the fundamentals to the most advanced topics, right? So if you can create textbooks for a particular topic, for a, let's say, Python programming, give examples, give ways in which errors could be made, give improvements for them and so on, and then you train a model on that, you can get a small model which is very good on this particular task. And this led to the Phi series of models. This says Phi 1, and since then Phi 2 has come out, which is a small, I think about 1.3, I think it's still around that size, $1.5 billion kind of a model, which is, the advantage is it is not only cheaper to infer, but it's also more controlled, right? If I asked it how to create a bomb or something like that that people worry about in the other general models, this will have nothing much to say because I have curated the pre-training data from scratch to only teach it certain kinds of things, right? So there is great value in doing something like that, both for efficiency and for control, right? So I think this will also open up, and creating pre-training data set at scratch again is not that expensive, and there are some interesting techniques out there which you can go create these data sets for a particular domain. So I think the full stack skill set, right, it goes from things that we are very comfortable now with, like prompt engineering, RAG. We talked about evaluating models also in the previous talks. Serving is becoming also highly commoditized. But then beyond that, right, how do you curate fine-tuning data sets? I don't mention it here, but fine-tuning is not just query and response pairs, but they also contain preference data. Is this response better than this response, right? And that leads to various kinds of human preference-based optimizations, both in terms of RLHF, but now there is a more accessible way of doing it, which is called direct preference optimization, much, much cheaper. So even that is now getting much cheaper. Then you, of course, need to be able to fine-tune these models. As I said, you need to be able to curate pre-training data sets. That's also an interesting skill. And then continual pre-training, and finally being able to generate synthetic pre-training data and pre-training from scratch. So my main takeaway is that as with any technology change, it changes the skill set required to win in that particular domain. And this is the skill set of this particular area. And it's not an AI domain, but it's generally writing software of a particular kind of software. Okay, so I'll just make a quick, I have, I think, 5 minutes left. I'll just make a last quick section where I ask the following question. Actually, it turns out not many people have made money with AI, right? So I've been in this field. It's not like Google or a Microsoft have made a lot of money selling AI. Of course, they use AI internally for doing a bunch of things, but let's say if you have a translation model or a speech recognition model, nobody became very rich doing that, right? And of course, they did it because they need it anyway, and you can put it out there, right? And for various other reasons. So the question to ask is, what can you do today with rupees 10 spent in AI, right? One thing is you can serve 1,000 ads. And that's what most of the internet is powered by. The #1 software category is search engines and what you can do with search. The next thing maybe, yeah, you can recommend 100 YouTube videos, and I mean maybe 100 Flipkart products or Swiggy food items. You can translate a 500-word article, right? These are rough kind of numbers that I just use from numbers that I know of. But what is possible with 10 rupees of AI in the future? I just wanted to give you some examples, right? So there are 6 examples. I'll talk about 5. The interesting thing is all of these are generated images. None of these people exist, so they are generated with DALL-E, and so none of these people exist, right? So one simple example is, imagine somebody a student studying in some tier 2 tier 2 school, and he asks a question like, I just wrote this a few months back when the movie came out, but if somebody asked if Hanuman and Thanos were to meet, what would they talk about, right? This is a curiosity-driven question. That's typically how education should be powered, but education being bottlenecked by content creation by teachers, you would not have something like this in a textbook, right? But if you created a scaffolded model that provides guardrails in terms of what children see, actually with 10 rupees, you can help somebody actually take this question, do a few rounds of conversation, and get somewhere, right? So the value of that 10 rupees of AI, you should think of very, very differently. Another example, here is a farmer who can speak in Punjabi, and he's saying something that written in Punjabi there. Somebody mentioned that these models don't work very well for Indian languages and Indian dialects. We should definitely be building models that work in Indian languages, so people like these could use this technology, right? The person is making a call, imagine an automated call, and saying, I farm on 4 acres, am I eligible for PM Kisan, right? It's a scheme from the government of India, and it turns out that if you are a small land farmer, then you are eligible, right? So who does this person go and ask it to? And of course, government will say there's a website contains the details and so on, but it's very inaccessible, right? So there is a bottleneck between a government and citizens, and something like that is possible to solve, again, using this 10 rupees of AI, right? Another example, it turns out this actually works quite well. This is in Kannada, and this lady is saying, I earn 20,000 rupees per month from May, and it'll increase to 23,000 rupees from July. I have so much savings, and my expenses are so much. By the end of October, how much will I save before Diwali? Again, I wrote this, I think, in May. And you can ask this question. You and I can use a calculator, can use an Excel sheet, Google Sheets, whatever, right? But this person, again, has a bottleneck not to have access to those. This is, in fact, not even 10 rupees. It's probably 5 rupees, right? It's very easy to go from a natural language input like this through things like function calling, through code interpreter, generate code, execute it on things like Google Sheets, which are very grounded calculators, come back with an answer, right? So can 10 rupees be used to do financial planning, loan understanding, or deciding whether I should actually purchase something or not? I think that's really possible. Another example, today we are driven by recommender systems, and the whole argument of big tech is that you should collect data at scale because this leads to better recommender systems. But there could be a different way of doing recommender systems, right? You could say that I like so-and-so movie for so-and-so reason very richly, and you can actually get recommended the next movie to watch, and with a very detailed reasoning of why you should watch that movie. Again, this is not going to be very expensive, right? In terms of the value it creates for the end user, right? The economics of it, when transmitted through a company, that we have to figure out, but consumers need things like this and may be willing to pay a certain amount for it, right? And this was also another example where, and this is now more real because of GPT-4V, you can actually give it example of images and say that, in this case of a person doing sign language, imagine that they are shooting video, and they say to the phone, this sign means something, right? And it means something because I am holding my fingers in this particular way, right? The way we do machine learning, even computer vision, is we show 10,000 examples and say this belongs to this class, right, in the older generation. But now you can say this image is actually this sign because my fingers are pointing in this particular way, right? And this is a whole new way of doing machine learning, right, where the model is not looking at spurious data patterns, but has the actual sequence of reasoning required to make a decision, right? Again, things like this is possible, but more crucially, the machine learning engineer in this case is that girl, she can go and train a machine learning model to understand her sign language, right? And therefore, we don't have to depend again on large companies building these things, right? I like to stop with that. I would like to just put out this quote from Vikram Sarabhai, who said that we must be second to none in the application of advanced technologies to the real problems of man and society. And I genuinely believe that this class of AI that we have here has a real opportunity for us to reimagine what value it brings to people at price points that they may be willing to pay. Thank you.